Yeah, now I can see the PPT.
Fine.
Okay, sir. Hello, very good morning. So my name is Vishwanath Mangoji, and I'm working as a technical lead at ZF India Technical Center. And here I take opportunity to explain my presentation, which I've done which I've done a project on eliminating the coupler connection failure at VST STI in assembly line 2. So here for carry outing this project, Mr. Amul Chaudhary has helped as me as a project guide. So I'll start with the presentation here.
Yeah.
Yeah. So now let's come to the abstract part. So where abstract in the sense, as you can see in the very competitive of our automotive world, as you can see, very lot of companies into the automotive and so a lot of competition is there. So everybody in their race, so everybody wants to reduce their manufacturing cost. So as you can see in the early trends in the last 5 to 6 years, everybody, there is no drastic change in the price of the automotive, and only how they are able to managing, because only they have concentrating on reducing the manufacturing cost. So it's a very stringent part where manufacturing, where we should concentrate on only on reducing the manufacturing cost. In that case, if we have the problems in the lines and the rework cost, that will definitely affect on the overall cost of the automotive. So here I take the opportunity where some of the some of the reworking, reducing the reworking cost of the side connector of in assembly line 2. So this is the abstract part and the introduction. So where I can say as you can see in the pie chart, so we are here. The problem was there were 783 parts per million, means parts per billion rejections per month. However, the customer demanded us to below the 100 parts per million per month. So as you can see in the pie chart, there were 5 assembly lines there, where assembly lines are there, where the assembly line 2 is contributing around 73%. uh, uh, which uh, which is the 783 parts per million per month. So here in the when we dig into the problem, so VST is the code of the side connector from the customer, and STI we designated to that model for our understanding, that is side turn indicator. So which is recently added to the line 2, where the ppm value of this model is increased, drastically increased from last 3 months. So the overall project is related on the product improvement of quality of performance of VST STI of the side line, which is assembled in assembly line 2. So the next part, so how we tackle this problem is we have segregated overall defects into 3 parts, which are A, B, C in 3 categories. So A type of defects are easily solved by the line members or the quality circle members, one to one problem into the one solution. And B types are can be solved with a cross-functional team. And the C types are require the management support in terms of cost approvals and all. For example, if the overall tool has to be changed, some tooling cost, this kind of costs need to be comes under C kind of categories. So for that we identified again overall 52 defects, 52 kind of defects which are repetitive in nature, which are affecting the ppm of the assembly line 2. So out of 52, B class defects were the highest one, and which were contributing more into which are contributing more for a coupler connection failures.
Okay.
So which was, yeah. So reason to select this theme was ppm and the cost of the poor quality, which was 3,996 that particular month of January 2019, which comes the overall COPQ cost was around 3,71,000. So that was our main problem, which is to be solved. So literature review, we should explain completely, or
As you wish.
okay. So here we used some of the quality. So to carry out this project, I, I have used my whatever the knowledge of this triple I section to triple I syllabus, and where I learned from the this academic year. So I use some of the quality tools like cost cost per PQ, which is where in the which I referred from the IBM quality expert, Mr. H. Harrington, in his book explained about the poor quality cost, where he designated as a poor quality cost, and for a period of time it is come as a COPQ, the cost of poor quality. And then we did the rejection analysis and the quality improvement. We did with some of the quality tools like statistical quality control, zero defect approach, Six Sigma, and TQM, quality management tools. So next to the how we approach this problem. So that is one part which is very interesting. We use a simplified approach followed by Quality Circle Forum of India. The problems solving is the initial first level of program solving. So which we use here, that is a 4M analysis we used, method, material, man, and so sir, I will just explain in the over next slides. So how we approach this occurrence of the problem, and is there any standards maintaining there? If yes, we go to the next whether they are followed or not. If it is there, if there are no standards are there, then we will define the standards. And next it goes to the nature of the problem. So how the nature of the problem, it is a chronic level, then we follow the QC approach. Otherwise we go with the viva analysis. So this kind of approach we followed here to tackle this problem. So then comes to scope of project. So what is the scope here we have to reduce our ppm here? So the aim of this project is to reduce the ppm, overall ppm, from 1040 to 0 ppm. In other words, so to reduce the ppm, what is the problem is the coupler collection failure is our problem. So instead for what we can say is, if we eliminate the coupler collection failure, then we can have the target of 0 ppm. This is our main scope here. The objective of this scope is to study the complete present situation and generation of this problem, and study the 4M analysis to countermeasure the same problem, to identify the root cause analysis to counter the same problem, and to brainstorm the alternate method to eliminate this complete root cause, and the ppm reduction from 1040 to 0. That is the main target of this project, and systematic action to sustain this the whatever the recommended actions here. So overall problem is here, what we through Pareto chart, what we analyzed is as you can see in the chart, the coupler collection failure was the highest contributor to the highest contributor to the high ppm of the line 2. So through Pareto chart we identify that is the one problem. So when we dig into that problem, as you can see in the picture, if I explain this overall problem is, this is the coupler connection where the coupler and the STI, where it gets fits. If it is correctly fit, then the side indicator will blow here. And if it is not fitting, so that there will be damage, so it will not blow at all in the vehicle. So it is there we also observe that it is a safety issue also. If it is not, if the side indicator is not blown, the driver will be the under impression that it is blowing and he will take the turn and it will leads to the accident. So here we one more major reason to solve this is, and there is another safety cause also there in our project. So if I can explain what is STI means, it's a site turn indicator. What is incomplete fitment here? Incomplete fitment in the sense, as I explained earlier, if it is correctly fit, the lamp will blow, otherwise it will not blow. So that is a one straightforward statement we can put here.
Good.
And what is the impact of this coupler fitment of STI? Impact, as I explained before, if it is impact is the major impact is the safety impact, and also it is it will increase our poor quality cost. So the causes behind this failure is the inspection method was inadequate. Inspection method was not as benchmark product. So whatever the benchmark product were using the inspection method, we are not using that. And the PCB terminal was not perpendicular to the PCB board. And the housing lock damage and housing lock dimension not as per the drawing. These were the major reasons what we find out while while studying this failure. So here we did some data collection methods, so which were basically the primary and the secondary, and which I learned from the triple I from the uh, total quality management total quality management study. And the primary data are which are collected from the investigator. So if I am the investigator, if I am studying this project, if I collected the directly from the data, so that is comes under the primary data, which are cost of MIS rejection and the poor quality cost, and the production target and the output, PPM trend overall. What is the PPM trend throughout my project period? Coupler collection failure, defect contributed from first time quality output. These are the comes under primary data, and secondary data which are earlier and without without not related to the my circle. So that kind of data which are registered. So for example, if some quality problems are registered in the ledger and all, those kind of data comes under secondary data. For example, coupler collection failure on line 2, also supplier generation at the supplier generation stage, inspection stage report, top quality defect impacting quality assembly line, Pareto chart of the top different contributor, determinant of the KPI target of cost parameter like rejection, rework cost, and poor quality cost. These are comes under the secondary data which we have collected, and the sources of data is workman managing the register, circle board, Gamba observation, and hourly the assembly line defects reports. And secondary data sources are the department production reports, MIS, journal, QID, and the some of from the websites. So how we collected data from monthly to monthly, we have collected, as you can see the this chart here. So as you can see the chart, in February there were product volume was 75,000. Out of that, rejection part of the STA was 4, and rejection cost was 616 rupees, and incomplete connection rework cost was 11,900, and the total poor quality cost was 12,516 rupees. As you can see throughout these months, so where we could achieve in the July month, it was completely zero. The production volume was same, but the cost of the rework, rejection, and include completely zero. So monthly basis, we have reduced the cost here. So production volume of the February, July month. So I'll go to the next slide, where the rejection cost is drastically changed from 616 to 0. And the rework cost was reduced from 11,300 to 0. And the rework cost of the month from February to July, if you observe, the 12,000 to, it is around 12,000 to in the July month it was 0. So health index of this actually the overall action was a rejection part rejection part of this product was before it was 79, and now it come to 5 after the our recommendations. Rejection cost of this part is 12,166 rupees. If you consider the cost of per piece is 154 rupees. So before it was 12,166. Now it comes to 770. Incomplete coupler fitment. River cost. River cost is 93,000. It is a very huge cost. So that we reduce 93,000 to 17,150, which is around 80% of the river cost we reduced here, and the total quality poor quality cost was 1,05,066. That also we reduced to 17,000. It's more than 80% we have reduced here. And this is the ppm. So here the target of the reducing ppm to 0, which we have achieved in the July month. Where when we started the February it was 453, now it is 0. So we achieved our target here. And then the analysis of the cause and effect analysis of this problem. So here we have done the 4M analysis: man, machine, method, and the material. So which are causing through the man? What are the man related causes? Those there are some. So as you can see, some of the which are we have described as which are significant and non-significant. I will explain here which are significant. So when it comes to significant, in the method column, we can see inspection was not proper, which we taken as a significant reason for this problem. And when it comes to material stage, so the PCB terminal not perpendicular to PCB4, which was a significant reason for our problem. And the damage of housing lock damage, which is significant again, and the dimension was not as per the drawing, which is also the significant. So here by doing the 4M analysis in the method and the material stage, we got some significant causes for our problem, which we need to solve. So test of hypothesis is done. Test of hypothesis is nothing but the where we don't know the truth. So unknown, we are following the unknown truth. Where so it's a just we will follow the regular method and try to analyze the what is the reason here, what is the truth of this cause. So before, if you see that in the method column, if you see the inspection was handling by the human. So it's completely depend on the person to person where how he checks it. So which is completely not recommended actually. So there will be a lot of human errors. And the material in the sense the housing lock dimension was not as per the drawing, which is a significant cause we identified in the frame analysis. In the material, so the terminals were not perpendicular to the PCB board, which were affecting the connection between the terminal and the coupler. So which one which we identified in the 4M analysis as a significant cause. So after this test, so why these problems are happening here? So for that we did the viva analysis. So if you take a inadequate inspection method, why it is inadequate inspection method is operator skipping the defects. Skipping it is skipping the defect in the sense he is not doing it purposely, but while as it's a human human inspection method, so there might be a human errors there. Due to that we stated as a skipping of the defect. And why he is skipping is judgmental variation. That's what I explained this one. So sometimes a judgment whether it is a right or wrong with a visual, if it is very hard to identify. And why it is judgmental is means again if it comes to the he is doing the visual inspection. So it's again person to person it varies. The root cause is it's a man oriented inspection here. And the second reason was PCB terminal not perpendicular to the PCB terminal not perpendicular. Alignment problem was there, which is comes under the material again. The position shifted from its original position. So why it is shifted? The terminal were bent, And the Y terminal is bend is the terminal is contact with the hard surface, which we identified at the flow stage, and direct contact of the terminal hard, which we need to address in the next stages. So through that, what we have achieved here by solving those problems, what we have achieved here is overall 93.67% of improvement we observed from earlier to after our project. Rejection cost was overall 93.67. We achieved around 12,000 to zero. Sorry, not zero. Around some 776 rupees. The reduction of recost is overall improvement we achieved around 81%, as I explained before. So reduction cost also we could able to achieve from 1,52,000 to 17,920 rupees. So reduction of the ppm, which were our main target, which we achieved. And the general observation what we observed is after implementation of corrective action, coupler collection failure has been completely eliminated from the assembly line 2 in May 2019. The workload of the rework section also reduced, thus their efficiency also increased. The delivery of the product has also improved. Half-day buffer stock is available in the assembly shop. These were the general observation we did here. And what we recommend here is, so overall we done the brainstorming in the work area and in the CFT team all over. So out of this, while doing the brainstorming, we got around 6 ideas. Out of 6 ideas, we took 3 main significant ideas which were solving our problems. There are terminal related. So to avoid the bending of the terminal should be rested on the hollow foam. So which is one of our colleague given the idea, which is accepted, and we have implemented that. And the second one is the partition of the bin to be provided at the assembly area. So where the terminals and these the partition should be done. Previously it was dumped in one bin, so which were affecting the damaging of these parts. So which we can avoid by giving the partition. And the coupler fitment checking machine to be implemented here. So we can, which earlier used to happen through the human, so we can avoid with the machine. So the human error could be avoided here. So as you can see here, before the terminal was directly kept on the prism boxes. So now the prism, the PCB, the packaging will be done on the foam, so which we can avoid the bending of the terminals. And before there were no partitions, then now we properly arrange with the partitions. So the contact of each part is avoided and the damage is avoided due to that. And the next, before, as you can see, the human error was eliminated completely through implementing the inspection machine here. So as you can see, if coupler connection is good, so it will blow. If connection is not good, it will blow in red. So he can easily identify which is not good and not bad, which is not good and good part. So overall result, as we can see, is ppm is completely reduced. We achieved our target. We achieved our main target here, and the overall the cost of poor quality we reduced from 1,05,266 rupees to 17,920 rupees. Okay. So these are the main targets we achieved here. And again, the scope of the further work is we can implement the same approach to the next lines also. So there are the scopes. We can implement the same methods to next lines to eliminate the poor cost and decrease the ppm. And the second is in the same kind of things. So there are again there are different projectors happening there. So we can instead of putting it directly, we can use this method to implement a new new product lines there. We can use the same method for new product lines also. So these are the references. As you can see, some of the references I have mentioned here, and the detailed reference list is mentioned in the our my project report. So thank you very much. This is the my project.
Good, Vishnath. Good. Your presentation was good. Few things I have liked the most, and there are few suggestions also and few queries also. So I would like to ask
Yes,
few
yes,
queries.
sir.
Okay. First thing is
Yeah.
why you have selected this project only.
So because so as I am working as a I am working in with my complete experience in automobile industries. If you see it now, I am working as a team lead in the ZF industry. So so it's a normal. It's my tendency to work towards eliminate the cost of the automotive. So I am aware of the trend of this complete automotive competence here. So when I see this problem, so it for me it's a opportunity to address this problem here. And also I used the triple I what I learned in a overall triple I examination, so which is also helping me here to uh,
Okay.
address this problem.
So how PPM is calculated?
So ppm is calculated, it's a part per million. So that there is a formula where we can calculate the ppm, so that I think
Okay.
I should again restudy it.
Okay. Okay. It's nothing but parts per million. So
Yes,
you have to identify the defects per
million
product into 10
product.
lakhs.
Yes,
Then you will get the PPM.
yes, yes. Into 10 days. Yes.
Okay, into 10 lakhs. So next is how COPQ is calculated in your project. COPQ, cost of poor
So
quality.
COPQ is
Uh,
cost of poor quality is as I mentioned in early slides of mine. So it's for per per so when it comes to the line which is rejected there. So from there, whatever the cost we are calculating for the rework part. So
okay.
that is
Your
per part we
for
calculated.
COPQ, we required
Yeah.
the river cost. Okay, agreed, which will include the
Yes,
manpower cost.
yes.
What else?
Yes, manpower, inspection cost,
Friction cost,
and
right?
again, yes, inspection cost and the material cost also
Right, material cost.
required. Material cost also it includes, and complete line the throughout the life cycle what that product comes from, that complete cost is involved here.
Okay, so that is yeah. So what is your project period? From when you started your project, you started collecting your data. So which was that period? Which was the period when you have taken the action? And from which month you started monitoring your project? The result part. So there are three phases.
Okay.
First phase is the data collection.
Yes.
So from when you
Okay.
started collecting the data, from which month to which month, then you implemented your ideas, kaizens for 2 months, 3 months,
Yes.
so which is that period and the monitoring period.
Okay. So that I actually I need to
Uh,
collect it.
you should be no. Okay.
Yes. Yes.
So you have mentioned your health index. Okay.
Yes.
Your project is
Yeah.
impacting the health index. As per my understanding, health index is the parameter which shows the performance of your department. So, in your
Yes.
case or in your project report, so these health index
Yes.
parameters are which one?
So health
Which are
index
those?
parameters we here I think we considered only for a line 2 here,
Right?
assembly line 2 for so overall health index we are not considered for the overall company because we are concentrating on only on the assembly line 2.
Okay.
So as you can see the numbers here, the rejected part before it was 79,
Agreed.
and after it is 5, and the rejection cost is 12,000 to 770 rupees, and incomplete
Here,
coupler
your health parameters are health index parameters are rework cost,
rework
income,
rejection.
uh,
Okay, okay, okay,
PM.
income. Okay,
All those
okay,
things are the
understood.
health index parameter.
Parameters.
Uh, so what I understood, your project, you selected this project because from safety point of view, this project is very critical because any malfunctioning in electrical system will directly impact to the tail lamp or
Accident.
headlamp. Yes,
Yes.
in your case, it's
Yes.
a side
Which
indicator.
is
So it is going to
yes.
violate the government norms.
Government norms.
That's why this project is
Yes.
critical. That's what was my understanding. Okay.
Okay.
So now there are few suggestions for you. First thing,
Okay.
write for each slide, make notes what you have to speak and how much you have to speak.
Okay.
Don't give
Yes.
explanation for each and everything. Okay. Because
Okay.
available time with you is only 12 minutes as per the feedback
12
taken from
minutes.
the earlier students.
Okay.
Okay. So
Okay.
hardly you will get 12 to 15 minutes. I will suggest that be ready with 12 minutes. Okay.
Okay.
And explain the key point. Be ready with the notes on which
Okay.
slide. On slide number one, what you are going to explain. On slide number two, what
Okay.
you are going to explain. If there are four
Okay.
parameters in slide number four, so on that four
Hmm.
parameters, on which parameters you are going to focus more. In case of YY,
Okay.
if you have done the
Okay.
YY analysis for the four causes, okay,
Hmm.
possible causes. So you have to explain only one in detail,
Okay.
and same way you have
Okay.
to say that similarly we had done the YY for the other things. Okay,
Okay.
it should be interactive session, interesting session. Okay, if you
Okay.
keep on saying explaining all the
Each and
statements and YY, then it becomes so
okay.
little bit boring session.
It's very lengthy.
Connectivity become, it's difficult to connect to the subject. Okay.
Okay. Sir, did you note how much time I took here?
From my side, from my experience, it's 12 minutes. No, in your case,
No,
now
sir.
20 minutes you
Yeah.
have taken.
Yeah.
You have
Oh
taken
my.
more than 20
Okay.
minutes.
I will reduce it down
So
then.
it's the
20 minutes
main
is enough.
reason for taking mock test is the same. The people, students
Okay.
should understand what they have to
Okay.
speak, because people
Okay.
directly go for the mock test and then it becomes very difficult. Even after
Yeah.
doing
Yes.
the
Correct.
project by their own, they are not able to present it, because doing a
Correct.
project is different thing and presenting your project is a
Yes.
different.
Yes.
Okay.
Correct, sir. Because if I have done completely, there again, so my words will be very clear and I will be very confident.
Yeah, presentation is
That's the
very
one.
important. Okay. Hypothesis test is done and okay. Okay, hypothesis test is done to identify because in any problem statement you have to focus more on fact, not on opinion.
Okay.
Hypothesis test
Okay.
helps you to identify the facts and gaps in your process, complete process, and it
Yes.
gives
Okay.
you the idea. So where you have to focus, which is valid cause, which is not valid cause. So to
Okay.
validate the facts, we are
So
using.
existing method only we analyze there, right?
Yes, yes,
We
yes.
will check the existing method.
Yeah. Okay. Last thing is that wherever you are using the shortcuts like QID,
Hmm.
quality, QID means quality information
Information.
data, QID, quality information data, MIS, monthly information system. That should be mentioned in the slide. Now it is not possible to mention it, but at least while explaining, just explain the complete
Full
full
form.
form of that words at least once.
Okay.
Okay,
Okay.
so that it becomes easy for the jury. Okay, overall good. All the best. Okay,
Thank you, sir.
do as much as practice you can do. Okay,
Yeah.
so all the best, Vishwanath.
Thank you very much. Thank
Okay,
you.
bye.
Thank you.